Okay, just a few comments leafing through the work I see on the Jacobian and then the divergence and curl and on line integrals. Not much to say. That, of course, hasn't been said in some of these examples. The whole art of being able to sketch the transformation of one region in a different set of coordinate, in a different coordinate system, is worth working on. And that's not just confined to 2 dimensions. Pretty neat stuff to be able to do, and I say that and being able to do it to whatever extent I can. Okay, interesting stuff on rotations of ellipses and so forth, and how you can transform the ellipse to a circle. But everything looks good, so I didn't see fit to comment on anything. The divergence and curl, what I conjectured number 40 seemed pretty obvious just geometrically, but I wanted to check it out, so that was the import of that video. I do have a comment, one problem to ignore my scratchings because you really don't want them to go viral. There's a comment on number 43 that these results are intuitive because there's no radial component. And that would be assuming you have rotation about the z-axis. Okay, there's no radial component to this vector field, and I should have commented on this when I did the video. So the curl, so the divergence has to be 0, and there is rotation, so the curl isn't 0. And of course, the bigger x and y is, the bigger your curl. Okay. Question on number 57. Be kind of interesting to try to work out the divergence in polar coordinates. Since you ended this this packet of work by working out directional derivatives in a path-independent system. I'll also comment that path-independent, or that coordinate system independent context. What happens if those 2 vectors aren't perpendicular? How would you do a directional derivative? Okay, looking at line integrals, and everything is pretty straightforward. Make sure you have an intuitive understanding of what the line integral tells you. The work integrals are all well done. At some point we should probably talk about why work is only due to the component of the force parallel to your motion at a point, and that's why you do an integral of f dot unit vector in the direction of motion, and that's what the line integral comes down to. So you want to make sure you think about that. Not sure when to go so deep into the physics as to talk about why that is, but just know that it is. Then when you take physics, you have the machinery to think about it and work it all out. So there are some work integrals. Yeah, satellites are very interesting. Because of course, once you set the satellite free out there in interplanetary or interstellar space, nothing does any work on it because it's always moving perpendicular to the force field. Actually, it's not true. When you set it free in space, yeah, force field can do work on it. It's in an orbit about one or more massive objects. Yeah, you're still getting work on it, so I don't know. I was looking at something while I was saying that. Your total potential kinetic energies remain constant. Okay, so it all looks pretty good. I've got your next packet. I'm going to have to sort the pictures out, but that won't take long. And hopefully I'll get back to you on that pretty soon.